So this video, we're going to do some examples of intervals of increasing and decreasing using some functions. So in this particular example, we have the function f of x equals x cubed, and we're going to notice that we have an inflection point at the origin. And remember, we said the inflection point is a point at which the function changes concavity. However, if I want to find the intervals of increasing, so I'm just going to sort of abbreviate if you don't mind, intervals of increasing, right? Hopefully you understand what that means. I'm going to use my interval notation, and I'm going to figure out, I'm going to ask myself, on which x values are the y values going up? Okay, that's what I'm asking myself. On which x values are the y values going up? Okay, so let's kind of walk along the x-axis from left to right, which is how I travel. And it looks like the y values are going up everywhere, right? So the intervals of increasing would be negative infinity to infinity. And we always use round brackets around infinity. Now, just in case you have a problem that would ask you this, you could be asked to find the intervals of decreasing, right? Where is the function decreasing? In that case, you would ask yourself, on which x values are the y values decreasing? And here you would just say none, because there's nowhere where the function is decreasing. Similarly, you could be asked to find the constant intervals, or intervals on which the function is constant. And you would also say none, right? Because the function is always increasing, even at the inflection point there. Okay, let's take another example. Let's make this one a little more interesting. We'll still do a cubic function, but we'll have some terms in it just to make it more fun. So example 2, and let's say example 2 looks like this. And this is not to scale, but you get the idea. Okay, so I have a couple points that I'm going to label. This is going to be the point negative 1, 2. This is my y-intercept of 0, 0. And this is the point 1, negative 2. So let's ask ourselves the same questions. I want to know the intervals of increasing. All right, so what am I asking myself? I'm saying, on which x values are the y values increasing? Okay, so I'm going to use my interval notation, and I'm going to walk from left to right. So I can see that coming from negative infinity all the way to negative 1, I am increasing. My y values are going up. So these are the x values on which the y values are going up. Now, importantly, I actually want to put a round bracket around negative 1, specifically because I don't want to include negative 1. Technically, at negative 1, I'm not really increasing anymore. I'm sort of standing still. If this were a roller coaster, my rate of change would be 0. So just make a note that technically you need to put a round bracket there, okay? Now, that can't be the only place that I'm increasing, right? It looks like also from positive 1 to infinity, I am increasing. But again, I need a union symbol, and I need round brackets around the 1, because technically at the point 1, I have a slope of 0, and I'm theoretically standing still. So I'm going to say 1 to infinity. Intervals of increasing. Okay, intervals of decreasing. Let's see if we can figure that out. Okay, now remember, the values that I'm putting in these brackets, these are x values, okay? But they describe on which x values the y values are going up. So now I want to find the intervals of decreasing. So I ask myself, on which x values are the y values going down? And it looks like it's going to be from negative 1 to 1. Notice again, I'm putting round brackets around these values. Are there any constant intervals? Any places where the function is completely constant? The answer is no, and you can just write none if that's a question, okay? Let's take another example. And in this example, I'm going to have something that you may recall as a piecewise function. So example 3. And let's see if I can draw this correctly here. So I'm gonna have this piece coming like that. There's an arrow, whoops, can you see that? There's an arrow on the left. This is going to be the point 0, 1. I'm gonna go straight across. This is going to be the point 2, 1. This is not to scale. And then I go down like that. So let's ask ourselves the same questions. Can I find the intervals of increasing? So intervals of increasing. And I'm not writing out the whole word increasing. Okay, so where am I increasing? For which, or on which x values are the y values increasing? So I would say from negative infinity all the way to 0. And technically, remember, I know it's kind of weird, I don't want to include 0, I want to put a round bracket there. All right, that's the only place where the y values are increasing. Now, are there constant intervals? Here's a great example of constant intervals. There are actually constant intervals here, okay? Where are they? They are going to be between the x values of 0 and 2. And again, I know this is going to sound a little weird. You actually want to put round brackets here. It's a calculus thing. Constant intervals just indicate where the x values are, or sorry, the y values are staying constant. So we're going to put round brackets around that. Constant intervals, technically the y values, right, are equal along this interval, okay? And then finally, do we have intervals of decreasing, right? So on which x values are the y values decreasing? And it looks like, yes, I actually do. Again, intervals of decreasing, I'm gonna say 2 to infinity. So the bottom line with the brackets is there's almost always you're almost always going to use round brackets. And in fact, I'll say always because I'm that confident that I can't think of a counterexample. You're always going to use round brackets to describe these intervals. So I hope that helped a little bit. You have actually a practice to do on intervals of increasing and decreasing where I have my worked out solutions. So please try that as best as you can and let me know if you have any questions.